So we've come a long way since the 90s. Back then, you would have some friends over, things would be going great, but then two of your friends would start having a disagreement over the release date of Ghostbusters. And this disagreement will start getting heated. Neither of them are backing down on their opinion. The mood of the dinner party is at stake. But it's okay, for you hold aloft the answer in your hands. For you are the proud owner of Microsoft Cinemania, giving you instant access to the history of cinema. Except it's not really instant, is it? Because first you have to go to the room with the computer in. And you turn it on, and all the fans start whirring. You get that friendly static crackle of the CRT monitor. And slowly and surely, Windows 3.1 starts to boot up. Eventually, you'll get your desktop, and then it has the audacity to do this. And that really sort of sets your expectations from there on, because we're dealing with an operating system that thinks booting up is a fanfare-worthy moment. And then you use Microsoft Cinemania, and by the power of multimedia CD-ROM, you reveal that Ghostbusters came out in 1984. And you did that in under 10 minutes. The dinner party is saved. The web really changed everything in this regard. The web, you get the information instantly. No installation is necessary. Native apps such as Cinemania and Encarta, they looked out of date pretty instantly. It became a weird idea to have a separate app for those things. Stuff on the internet was better. It was built with this new, interconnected, modern world in mind. The browser started to replace more native apps. So I think email clients were probably one of the first to go. But then things like office tooling, video players, code editors we're seeing now. Native apps are pretty much the exception these days. If you look at Amazon's list of top-selling laptops in the UK and the US, there's multiple Chromebooks in there, and they don't have native apps at all. And this is how secondary native is becoming. Although that's not so true on mobile. Their native apps still rule, because they build to the strengths of the platform. A lot of the web predates mobile. Some of the web is pretty hostile to mobile. This is a creative agency, which I won't name, but this is what you get if you go to their site on a phone. It says, choosing your creative agency isn't like buying a pair of shoes, so why don't you make yourself comfy and visit our site on a real screen? But they're right, though, aren't they? Choosing creative agencies is not like buying a pair of shoes, because I have never had a shoe tell me to fuck off and come back when I have real feet. If you go to their desktop site, things are much better. It shows you the sites they built. You get the things they're expert in, which of course includes responsive sites. This is hostile to the whole mobile platform. But actually, the more worrying case for me is sites that are just hostile to the mobile web. This is a horrible situation. The user has gone to these places in a browser, potentially following a deep link, and rather than giving them the data they want, we send them to another place where they can download a thing and install a thing, which they can run, which may contain the thing they were originally wanting somewhere within the UI. I don't think anyone's suggesting that that's a good user experience, but it's one that some developers, or some project managers, project designers, think is worth it to get users off the web and onto a native platform. And why is that? Think about the native apps you use, the ones that you depend on day to day. Those are places that the web has failed. What caused that failure? Why can't those things be replicated on the web? For me, these are the apps that I use frequently or I completely depend on. And they can't be done on the web because of things like push notifications. This is vital for the apps in yellow, especially to me. They tell me someone sent me something, or something happened, or is about to happen, and that happens in the background. I rarely open TripIt. I kind of forget I have it, but then it will send me a notification saying, "Oh, you need to check in for a flight," or "Your flight's been delayed," or "Here's where your hotel is." It's vital information to me. Background synchronization, update data in the background is vital for these apps. From downloading podcasts to sending an email later that failed to send at the time due to connectivity, which kind of brings us to the offline stuff. I depend on this for more apps than I realize, like pretty much all of these. From playing music to checking where my hotel is, where I'm supposed to be at a particular time, looking up a meeting location. I don't want to have to depend on connectivity for these things. That would be really frustrating. And of course, we need better performance and operating system integration. You know, we need icons where the user would expect to find icons. We need battery stats, like we need to know which sites are using up more battery or using more background processing, and account integration, payment integration. Everything that makes it first class on the platform. The web can't do these things, and that's a bug. But what gives me optimism is it's bugs that we're fixing. We're actively landing code at the moment to fix these things. These are the ones I want to talk about today because they require something new. Background sync happens in the background. Push notifications that are handled in the background. Offline isn't so much a background thing, but it requires something to be bigger than the pages itself, something that can control the pages. And that thing is the service worker, which I want to talk to about today. This is the slide at Google I/O that got a round of applause, but never mind. That's fine. Don't worry about it. It's okay. No, don't patronize me, Jeremy. Look, at Google, I tested at Google I/O because I was watching the keynote, and people seem to be clapping just when people said a number. So when I started my talk at Google I/O, I just walked on stage and went 300 billion and left a gap, and people started clapping, and I was like, I love this. It's great. I should have really dressed this up a bit to make it more impressive. I really love what graphics cards do in this regard, because graphics cards are just a circuit board, right? They don't really do anything in of themselves, but they kind of dress themselves up to try and sell themselves to gamers as something they must have. And the artwork on the boxes is incredible. It's like this sort of poor deviant art crap that you end up with. Like, you get the usual sort of sexist rubbish that kind of ties itself with gaming a lot, but also stuff like the hideous offspring of Shrek and Yoda was on one of the boxes I had, or Teenage Mutant Ninja Dog. Yeah, they're all sort of knockoffs of other things. So in that vein, I present to you the service worker. Thank you. That's Mumra, the ever-living there, juggling browser features. We really need a designer to make us a logo. We need to stop me before I design again. But this is a feature that's being worked on between Google, Mozilla, Samsung, and other third parties. It's like a shared worker in that it's shared between many pages. It doesn't have any DOM access, and it's shut down when it isn't in use. Unlike a shared worker, it can exist without a reference to it. It can start pages. It gives us this JavaScript context to do all this background stuff. It's still heavily in development, so if you want to play with it today, you'll need Chrome Canary or Firefox Nightly. And in Chrome Canary, you'll need to go to About Flags and enable experimental web platform features. And once you've done that, you'll need to restart the browser. If Chrome isn't your thing, then Firefox Nightly has it as well. So about config, and you'll need to go to dom.serviceworkers.enabled, and then once again restart the browser. For the demos in this talk, I'm going to stick to Canary for the demos because they pay me, so it would be only polite. But the debugging tools are also further ahead. In Firefox at the moment, you're kind of working in the dark, but they're going to fix that soon. If you want to know what's supported and where, is Service Worker ready? It gives you a sort of feature breakdown of all the different components and shows you which browsers have support for that. So let's take a look at the offline stuff first, because it is a foundation for the other features. Offline suffers from the same misconceptions as progressive enhancement. I find, like, people say, my site doesn't need to work without JavaScript because all of my users have JavaScript enabled. No. None of your users have JavaScript until they have downloaded your JavaScript. You can shave seconds off your content delivery by getting to first render before JavaScript. And similarly, people are saying, like, I don't need my site to work offline because all of my users have permanent internet connectivity. Once again, no one has connectivity to your server until they have made that connection. And that takes time. So instead, we want to treat the network as an enhancement that might not be there. That's offline first. Get as much content on screen as you can before you need the network or while you're getting the network set up. And then your site will be faster. It'll be faster for users with full connectivity, because going to disk is most of the time faster than going to the network. It will give something to users with no connectivity, because otherwise they get nothing. But most importantly, it saves the sanity of these users. This is worse than no connectivity, because at least with zero connectivity, you get instant failure. You get an answer straight away. In this state, your phone can take 10, 20, 30 seconds to do anything. The network is our bottleneck. When a user clicks a link to your site or they open a new tab, we create a document, but we need to populate that document. So at the moment, that comes from the network. So off goes our request, and that can take a long time, and slowly it comes back. But we can't even render at this point, because we have to send requests for all the sub-resources, the CSS, the JavaScript, the images. As these come back, we can start to render. But we're still not done, because those sub-resources trigger other sub-resources, like the images used by the CSS, XHR, fonts. And then we can get to full render. And that can take a long time. For a practical example, I'm going to look at this site, which is a kind of demo site, Trained to Frill. Don't ask me. It just displays like the latest train photos from Flickr. Don't ask me why trains. I built it. I was on a train. I had zero inspiration at the time. But it's a simple demo of how many sites kind of load. If we look at it on a phone, this phone's going to be throttled to an edge connection. So that's 250 kilobits. So it's not the fastest connection in the world, but 15-year-old me would have killed you for a connection that was 250 kilobits. But this is how this site loads in 3, 2, 1, go. Right, so we get a render after about a second. We're waiting around a long time to get the data from Flickr, which tells us what to display. We haven't got any images yet. These images are 200K each. That's what Flickr gives me if I wanted enough pixels to cater for a device of this density, because this is a 1080p screen. We get the first image through after about 30 seconds. A few more images are coming through. And then after what feels like forever, we will get all of the images. And that takes over a minute. I had to cut this video down. I mean, that wasn't real time. Those are the real-time figures. Of course, we could probably recompress the images a bit. I just took what Flickr gave me. We could probably do something to ensure that the top images load first. But it's important to note at this stage, we are still winning compared to native. The native equivalent is the trip to the App Store, the download, the install. And that's a slow and comparatively poor user experience compared to this. But native kicks our arse on the second load and all subsequent loads, because it uses that initial download to cache a load of stuff, to prepare a load of stuff. We have the browser cache, but you're fighting the whole web for that. And the browser cache isn't very smart. It will get rid of your stuff in favor of something maybe the user doesn't use as often but is a bit bigger. And also, we tend to deploy sites really frequently. It's one of the great things about the web is we can just update stuff. But if we change one line in our CSS, then that whole file is invalidated. We tend to change the file name of it to deliberately break the cache. So, the browser's cache isn't as useful as we sometimes think it is. But this page solves a lot of that by registering for a service worker, one of these new things. And it does that just with this line, very simple line of JavaScript. And just gives the location of the script. You can also specify a scope as well, so you can say, I only want this to act on a subset of my origin, which is useful for things like GitHub pages, because you have lots of sub-apps on there. Google has a lot, like /calendar. The default is the whole origin, which we're going to use. Registering is an async operation, so it returns a promise. So you get callbacks depending on whether it succeeded or failed. If you're unfamiliar with promises, now is the time to become familiar, because all DOM operations that are kind of async, success, failure based, they will all be promises now. And we see a lot of APIs already that are promise based that are in browsers today. If you want to read up on how they work, there's an article on HTML5 Rocks. Every visit to that page helps me justify my employment. Seriously, at the employee review time, I point to that. So give it a few clicks for me. Thank you very much. You can only register for service workers on pages that are served over HTTPS, ones that are served securely. And that's because we cannot afford to give the control you get with a service worker, we can't afford to give that to a man in the middle. If you're communicating over HTTP, the data can be tampered with by anyone in between. And that's not just a concern for stuff you're sending to the server, it's also a concern for what you get from the server. When you read BBC News online, that's HTTP, which is most news sites are still. You don't know if you're reading the content the BBC sent or content that someone along the way edited or added or removed. And this is people like an intermediate router, an ISP, a government. We need HTTPS everywhere. And this isn't a theoretical concern either. I went on a holiday to Istanbul a couple of months ago, and I came back and I was browsing the web on my phone, and I was getting pop-ups for Turkish sites. Like, no matter where I went, well, the common theme between them was it was all HTTP pages. And what had happened is some router, because I was using a lot of free Wi-Fi because I didn't want to roam, some evil router in some pub somewhere had poisoned a CDN copy of jQuery. So any pages that were using the CDN copy of jQuery, I was running this attacker's code. And they were able to launch pop-ups. And it's, you can't do that on HTTPS. That's why we need it. I had to flush the cache, and I was free of it. But if that was a service worker, then it would be owning whole origins and controlling the content, which is too scary to think about. Thankfully, things like GitHub Pages, they give you free HTTPS hosting. It's a great place for demos and projects. And localhost is exempt for development purposes. So as for this worker script, what we're going to do, let's just add a console log. We're also going to listen for the install event. This happens when the browser sees this service worker for the first time. So let's see this in action. I'm going to go to service worker internals, which is where our debugging stuff is living at the moment. As you can see, there's no service workers there. The browser isn't aware of any. But if we open up the train site and DevTools along with it, we can see that the service worker has successfully registered down there. And if we go into service worker internals, it should be in there as well. So yeah, there it is. And it's in an activated state. But better than this, we can see some of the console logs here, but they're difficult to read. But we can click inspect, and we get a full DevTools window letting us run code on the console, set breakpoints, inspect things. We've already got more debugging power than AppCache ever had at this early stage. If I fast forward time a bit, at this point, the worker terminates. That's not a bug. We do that just to conserve memory. It's not in use, so we shut it down. So at that point, congratulations. You are now wielding the power of the service worker. But what does that actually get us? Nothing. Absolutely nothing. But wait, that's actually a good thing. I promise you. Apple used the word unapologetically to turn bad things into good things, so I thought I'd give it a go. But you compare this to AppCache. If you give an HTML page a manifest, just like that, and it contains just the words cache manifest, which is required to make it valid, yeah, sure, I'd expect my page to go from this to this, said no one in the world ever. We didn't want to repeat that problem. So Service Worker doesn't do anything unless you tell it to do something. AppCache broke a lot of eggs and failed to make an omelette. It's pretty bad. But it is actually made of the right ingredients. There's routing, fetching, caching, updating and version control. It's all good stuff. But in order to get to them, you must first traverse the piles of implicit behavior, which of course are guarded by the robot wasps. If you've used AppCache before, you'll know exactly what I mean. So we cleared all that away. We got rid of them. We just gave you the component parts so they can be used however you want without getting stung. This is the extensible web. Don't let the platform give you a fish. Say, no, I would like the fishing rod and show me how to use it. And I will take the fish as well. This is part of the extensible web. We want high-level APIs and low-level APIs, not just one or the other. So first up, let's take a look at routing, putting you in control of requests. So we've already seen the install event inside a worker, but there are other events as well, such as fetch. This fires for any navigation within your scope, but also for any sub-resource on those pages. So as an example of that, in Service Worker internals, I'm going to start the worker and inspect it. And we can see the code I just showed there. There's the fetch event with a debugger statement. And now if I navigate to the page, we hit that debugger for this request, for the root page. If we move on from there, we'll get another one, this time for the CSS. If we move on from there, we get one for the logo. Note that we've managed to get to first render before the JavaScript has come in as well, because we care about performance. If we move on from there again, there's the JavaScript. And then we get the API call to Flickr to see what images to display. So even though this request is to another origin, we still get an event for it. And then we get events for all of the images as well. We don't just get the URL either. You get detailed information about the request, like its headers, what kind of mode it is, the referrer. As much detail as we can give you without breaking the security model of the web. But the cool bit is, like other events such as click, key down, touch start, whatever, you can cancel the default and do something else. You can respond with something else. Responses can be created manually, just with the new response constructor, and add some text in. That's fine. And that will change the response from this to this. But the interesting thing there is we just responded without going to the network at all, making it the first offline demo only over halfway through. I actually need to speed up. But we can do better than that. When the browser discovers the service worker for the first time, we'll send it off to the web. Send lots of requests to the network and get a load of responses. That might be fast, it might be slow. The network is unpredictable, but it doesn't matter because we're not disrupting the user at this point because they already have the page. We're doing this in the background. If all our responses come back successfully, we'll dump them into a cache for later use. This is kind of good for stuff a native app would do as part of the initial download. Things like, for us, it would be the page, the CSS, the JavaScript, the design, images, all the static stuff. And then in future, when we get a request for one of those things, we'll just get it from the cache and send it back. We don't have to care about the uncertainty of the network. And this is really simple thanks to the caching API, which gives you full programmatic control over the cache. In terms of our train site, in the install event, we get this event.wait until, if we pass that a promise, we can extend the install event or indicate its success and failure. So in here, I'm just going to create a cache, give it a name. That gives us a cache object. And then I'm going to add stuff to the cache. Just going to add all the static stuff, the SVG logo, the JavaScript, CSS, that kind of thing. If this fails, the whole install fails because it creates a rejected promise. But if install succeeds, then we can guarantee that we have all of this stuff in the cache. It becomes our dependencies. To tell us more about Chrome's implementation of the caching API, we now go live to Senator Vreenak off of the Romulan Empire. Senator, tell us about the cache API.
It's a fake!
Thank you, Senator. I've been watching DS9 again. It's actually really terrible. But anyway, I've got to push through. The API that's in Chrome currently, in Canary, is a fake. It's not the proper API. Thankfully, there is a polyfill that's backed by IndexedDB, which works fine, and that's going to be the final API. The proper implementation should arrive in a few weeks. But how do we use these cached items once we have them? In the fetch event, so here I'm reacting to a fetch, and I'm calling caches.match, passing in the request. And matching here is based on URL, method, and vary headers, the same as the normal browser cache. It'll get out whatever matches and send that back to the browser. If nothing matches, you'll get null back, which is going to be like a network failure. But promises let us recover from that. So here I'm saying I'll return response, or if that's going to be falsy, we'll return something else. We could return another item from the cache, like a fallback page. But what if we wanted to try the network? To do this, we need to be able to make a request using JavaScript. Back in 1999, Microsoft engineers were working on an exciting new API. But what to call it? But what should they call it? It contains some abbreviations, some initialisms. So should they make it all caps, like HTML in inner HTML? Or just the first letter, like ID and getElementById? So they did both. An XML HTTP request was born. Other than that, the name is perfect. It's XML because it only deals with XML, except it doesn't. HTTP because it's restricted to HTTP, except it isn't. And request because you get a request object back, except you don't. We have tried to modernize this API over the years, patch it up, but it's still pretty bad. Like if you want to fetch some JSON, it's this gnarly, horrible code, and we've been patching it up for 15 years. I do not want to be using this API when it is old enough to drink, and that's only a few years away. Thankfully, the fetch spec by Arno van Kesteren of Mozilla, it kind of gives us lower-level access to requests and responses and fetching. We've seen some parts of it already, the request and response constructors and objects. But there's also another part of it, fetch. Lower-level APIs are generally more difficult to use than higher-level ones, but XHR is so bad that that is not true here. The equivalent for this stuff in fetch is you fetch a URL, that gives you a promise. You parse it how you want, that gives you a promise, and you're done. This is a forward-thinking API as well. ES6 arrow functions make it a lot neater. ES7 async functions can turn it into kind of familiar synchronous looking code. It's not actually synchronous. The word, when you use a keyword await, that pauses your code and waits for the promise to resolve and gives you the value back. But it's an asynchronous pause. It's not going to lock up the browser. In fact, using ES7 async functions, you can turn this into a one-liner if you want, which you certainly can't do with XHR. So to answer the question, how do we send the request to the network? Just fetch it. So where does that get us? What's the improvement there? Well, 3, 2, 1, go. We get to first render almost instantly. We get to content render after about a couple of seconds. We're still going to the network for this, but our JavaScript arrived a lot sooner, so it was able to make that request sooner, which is why it takes a lot less time. It's still a sad story with the images, unfortunately. They're taking forever, but let's fix that. So when we get a request in for an image, it goes to the service worker, like all requests do. And if we have it in the cache, we'll just return it. If we don't, off we go to the network, and we'll get a response back, and we'll send that to the cache and the page at the same time, so it's there for next time. We're doing this for Flickr images, but this is useful for things like avatars and lots of other kinds of content. To do this, we special case URLs that contain, end in staticflickr.com. Well, the host name ends in staticflickr.com. And then we call another function. And all we'll do there is we take the request, try and get it from the cache. If it's there, we return it. Otherwise, we fetch it from the network and cache.put. We put it in the cache at the same time, and we return it back to the browser. We're adding to the cache with every request at this point, so at some point we want to kind of take care of that. We want to garden it to make sure the cache doesn't just get bigger and bigger. We'll pick that up later, but for now, let's see how that improves things. So 3, 2, 1, go. Once again, early on the first render, 2 seconds for the content, but this time we've got images. We've got all of the images that we've seen already. We haven't seen this one before, so that takes a little bit more time, 11 seconds. But that's pretty good on a throttled connection. But we're still dependent on the network for that API call to Flickr, so we don't work offline aside from the top bar of the page. Let's fix that. So when we get a request for this API, the page makes a fetch request. That goes to the service worker. But at the same time, the page also goes directly to the cache. And if it finds something in there, it takes it and it renders with it. And that'll be old content. But the images that it finds in there will also be in the cache, so you'll get a really quick first render. Meanwhile, in service worker land, it's going to make a request to the network and get a response back. And we'll do what we did before. We'll send that to the page and the cache. With this pattern, the page makes 2 requests. It renders content twice, once with the content it's seen already, and another with new content. This means we get to render really fast with old stuff, but we still get up-to-date content. The best native apps do this, and I mean the best. Very few of them get it right. Twitter is a pretty good example. When fresher content comes in, it kind of adds it to the top of the list, but it doesn't disrupt scrolling. Facebook gets this pretty wrong, that you'll be reading cached content, and then it gets new content, and it just swaps it in. Like whatever you were reading is gone, even if you hadn't seen it before. You'll have to scroll to find it. So I think the web is in a really good position to take over UX-wise here and sort of beat native at this game. So here's where we're at. We're going to special case api.flickr.com as well, do something else there. I'm not going to go through this code line by line, but we're basically fetching from the network, putting in the cache and returning to the browser. This gnarly bit in the middle is where I'm going through the images cache, because I've now got a new response from Flickr, and any images that are referenced in this new API response are the ones I want to keep, so I can go and delete the ones I no longer need, and that's how we keep that image cache API small. Even with promises, it's kind of ugly. You get this sort of pyramid effect. ES7 async functions make it a lot cleaner. So, but this technique requires the page to make 2 requests. So the code on the page is about as simple as this. We've got up at the top there, this is the network request, this is the cache request, and we race them, we set them off at the same time, which is another thing that native apps don't do so well. Because it is possible for the network to beat the cache. We see this a lot on Windows machines, because Windows machines come with virus scanners. Like you buy a Windows machine in a shop, they come with 5 virus scanners on, and that makes disk access slower than going to the other side of the world for your data. So this is if the content from the cache succeeds, but then the network fails, we can just fail silently at that point. That's a pretty good offline experience. Unless the user has explicitly pressed like a refresh button, then we need to say, look, no, that hasn't worked. That was probably too much code to show on slides. I just wanted to sort of get across, we're expressing relatively complex and custom async behaviors in relatively small amounts of code. And we're doing exactly what we need to do for a given situation. Even using the low-level primitives, it's not that much code. And the effect of this? Well, let's remind ourselves of where we started. So without the service worker, 3, 2, 1, go. Over a second for first render. And then it feels like an age until we get anything else. And I'm not even going to wait for the images to come in because it's forever. But with the service worker and the code we've written to do the caching and the network handling, 3, 2, 1, go. That looks like a fully rendered view. And now we're told that we've got some new content, but we have to scroll to get it. It's not disrupted the experience we have. In that example, we were getting what looks like a fully rendered view in 0.2 of a second. And this is in an early implementation. That's going to get faster. And then fresh content came in after 2 seconds, but it wasn't disrupting us, and we get the fresh image after 9 seconds. So we're beating the initial one by second for first render, but then like 30 seconds for content. With Service Worker, you can get content on the screen in a fraction of a second, whether you have a fast connection, a slow connection, or no connection. And this is what catches us up with native start performance. This demo that I've built, and I can show you on a phone in a bit, but it actually starts up. Even though it has to start up a browser, it's faster than a lot of native apps starting up. This also gives us the foundation for any of these other things that are event-driven, such as push notifications and background sync. We're also looking at alarms, geofencing, and intents to be sort of built around this model. These haven't arrived in Canary yet, but they are coming soon. First up, push notifications. I depend on this for so many apps. Before we look at the code, I'm going to be brave, and I'm going to try to do a live demo. Right. Don't need the Wiimote for this. So what I'm going to do is I'm going to start a simple chat application. Oh, that's not what I wanted to do. Where's Firefox? Excellent. So I've got a phone here, and I'm going to... Hopefully this will appear down here. Yes, it has. Excellent. So I'll clear all the notifications. That's quite bright. Hopefully Right, so you can see that. Excellent. So I've got a simple chat application. Hopefully this will work. If I write hello on here, sometimes I need to restart Chrome to make this work. No, there we go. Okay, so hello's appeared because I typed it in this other window. That's not anything new. We're just doing that with some WebSockets. That's an old story. But what I'm going to do now is I'm going to close all of the apps that I have open, absolutely everything. So there's no apps now running on my phone. But in the same chat window, I'm going to say hello again. And if the live demo gods are on my side. So what's appeared there, and this is just using a W3 spec that's being worked on. We have a native push notification has appeared on my phone. There you go. So it's hello from Jake. And this is all using the open web. But because what we've created there is a native notification, it's also appeared on my watch. The brightness will adjust itself in time. Yeah. So this is just using open technologies, and we're able to do the kind of stuff that we thought was previously just native only. But how do we make that work? So the code for that is pretty simple. From your page, when you've got a service worker registration, you call push.register, and that gives you the details that you need to be able to send these push messages to the user. And that will be an endpoint, which will be GCM for Google Cloud Messaging. APN, I think, is Apple's one. Firefox have their own as well. So it'll depend on the user's device. And once you've got that, you'll send that details up to your server, associate it with the user, so when they get a new chat message or a new email or whatever, you can send them that message. Over in the service worker, when you send one of those messages, the service worker wakes up, you get a push event, and then you can do what you want. Usually it's something like look at the data in the push message, update some caches, and then show a notification. This is one thing that native apps get really wrong, is they don't, very few of them, update the caches before they show the notification. Twitter, which does offline pretty well, gets this wrong here. This happened to me this morning. I looked at my phone when I was on the underground. I had a Twitter notification. I get the first line of it, just what fits on the screen, and then I click on it, and I'm presented with nothing because I have no connection. And now the notification is gone. I'm now in a position where I have less data, less information than I had before I clicked the notification. You also get an event when the user presses the notification. You can do what you want there as well. Typically, it's going to be opening a URL. You can also focus an existing tab. You'll be able to hide the notification if the user clears a notification on another device, because you get events for that as well. There's also background sync, which is very similar to push, but it doesn't involve as much server interaction. This just lets you open the worker up at some time to do something. For instance, you might try and send an email and it fails. So you register for, you save that stuff into an outbox and you register for a sync event. Just say, hey, I need to do some background work at some point when the user has a connection. This stuff, including the push messaging, is likely to trigger a permission dialog. So the user can say, yes, I want a site to do this, or no, I don't. And then sometime later, you'll get the sync event over in the service worker and do what you want. In our case, we'll get the outbox and try and send all of those emails. This was a single sync event, which is just saying, look, give me a chance to do something when the user has connectivity. You can also register for things to happen on an interval. So this would be sort of updating things. The interval is it's like the minimum that you want to update with. It will be based on heuristics. Like, if you request a daily update, and we know that the user goes to your site at 9 o'clock every morning, we'll schedule the sync for 10 to 9. You know, we'll try and do smart stuff there, and we'll coalesce it with other events to save battery power. So with Service Worker, we gain a lot of the features that make native superior at the moment, but we retain the bits that keep the web superior, the instant on, no install required. It's an open platform. Google is going to ship this stuff to stable, well, a lot of it this year, and some of the more of it next year, especially the sync and push are going to be next year. Microsoft are investigating it. Mozilla are actively developing it. We haven't heard from Apple yet, but that's not unusual at this stage. They tend to sort of come in after other browsers have implemented it. But this is designed to be used as an enhancement. Like, the first time a user visits your page, even on a browser that supports Service Worker, it's not there yet. It hasn't installed yet. So you need to make sure your pages work without them. So as soon as this hits Chrome, that's like 750 million users have this capability. And you can use it without disrupting other users, just with basic object detection. Service Worker doesn't make stuff work offline. It doesn't turn push messages into cached content and notifications. It gives you nothing for free, but it treats you like an adult. It gives you all of the moving parts. It says, here, do what you want. Build something that makes something work offline, or build something that we've never thought of before. A client-side wiki we've seen already. When streams arrive, you'll be able to decode video like maybe the browser doesn't understand into a format it does without loading the whole video in memory, and that stuff's going to be really powerful. Make things work offline, do these things in a way that makes sense to your app, the way that gives the best user experience. I'm heavily biased about this stuff, but I think this changes the scope of the web more than any feature since XHR. Let's build some cool stuff with it. Thank you very much. Yes.